All right, this is Algebra 1B Part 1, Unit 2, Lesson 1. We're going to look at zero and negative exponents. Zero and negative exponents. So first I need to define what an exponent is. So let's take a look at exponents and then we'll look at zero and negative ones. Okay. An exponent is a number on another number that tells you to do something with it. So 5, I say this is 5 to the second power. 2 is the exponent. It tells me how many times to multiply the base, which is 5, by itself. So I'm going to write 5 squared equals 5 times 5. So the base gets multiplied by itself and it appears twice, right? It gets multiplied by itself twice. That's an exponent. So another example, I could do 4 to the third. That means 4 times 4 times 4. Now I want you to notice something. 3 is not part of the calculation. It's 4 times 4 times 4. Nowhere do we multiply by the exponent 3. The 3 simply tells me how many times the 4 appears as a factor in the product here. And how many times it gets multiplied by itself. Okay, so that said, that's what an exponent is, that's what a base is, and the whole thing taken together is called a power. Okay, and functions that are built like this are called power functions, and so on and so forth. But exponent and base are important to understand. So let's see if we can make sense out of an exponent of 0 and an exponent that is negative, because those don't make a whole lot of sense. And does a base appear 0 times, or can a base appear negative times? That's kind of confusing. Well, let's take a simple example here. Let's take 2 to the second power. We understand that means 2 times 2, which is 4. Okay? And 2 to the third power, that means 2 times 2 times 2, which is, got to think about that, 2 times 2 is 4, 4 times 2 is 8. Okay? And 2 to the fourth power is 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. I'm going to do one more. 2 to the fifth power is 2 times 2 times 2 times 2 times 2, which is, hopefully you're sensing the pattern here. Every time it doubles, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Okay? So as I go up the list, as the exponent keeps going up, we keep multiplying by the base. One time. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32, right? Okay, so hopefully that makes sense. Every time we increase the exponent by 1, we multiply by the base again. All right, so let's go in reverse order. Let's go backwards. Okay, 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. So let's carry this to the next logical step and let's go backwards. What is 4 divided by 2? Hopefully you've got the idea that 4 divided by 2 is 2. 4 divided by 2 is 2. And lo and behold, 2 to the first power is 2. And notice how many times the base appears. It doesn't get multiplied by itself at all. It just is itself. 2 to the first power is 2. By the way, that brings up something. If I have the number 2 and want to write it as a power, that is the same as 2 to the power of 1. So if no exponent is written, it is 1. The exponent is 1. That's similar to something we learned about fractions. A whole number can be written as a fraction by putting it over 1. Well, a whole number can be written as an exponential or a power by putting the power of 1. Very similar idea. All right, so that said here, let's look at, take this pattern one more step, right? And let's do this. Let's take and divide by 2 again. Divide by 2 again. What is 2 divided by 2? Think about it for a little bit. 2 divided by 2, or 2 over 2. Anything divided by itself is 1, right? Anything divided by itself is 1. So if I take this down to the next step, what are the exponents here? 5, 4, 3, 2, 1. The next one in that pattern is 0. 2 to the power of 0 is 1. It's 1. 2 to the power of 0 is 1. And think about it. 2 divided by 2 is 1. And the pattern going forward still works too. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Whoops, 4 times 2 is times 2. 4 times 2 is 8, and so on and so forth. So the pattern continues. So here's the rule for 0 power, right? It literally is anything to the power of 0. If I raise anything to the power of 0, the answer is 1. Now you can imagine some really ugly problems that really get simplified very quickly. For example, 1263.5 to the 0 power is 1, right? X squared over 4y plus 7z, or z squared minus 2xyz, all raised to the 0 power, is 1. It doesn't matter what it is. If I raise it to the 0 power, it is 1. Now there is one exception that we won't get into much, and that's if you try to raise 0 to the 0 power. And that, questioning what even that means, because you'd have to divide 0 by 0, and you can't divide by 0. We won't get into that. So remember the rule, anything to the 0 power is 0. Now let's continue this on. I'm going to grab this, and I'm going to move it here a little bit. We're going to continue the pattern. We're going to continue the pattern, but we're going to keep it going on up the list, kind of going up the list. So we're going to keep dividing by 2, right? So what is 1 divided by 2? 1 divided by 2. Let's think. 1 divided by 2. 1 over 2. Ooh, wait a minute. That's a fraction. You might be tempted to think 0.5, but I want you to leave it as a fraction. 1/2. So let's continue the pattern here. 5, 4, 3, 2, 1, 0. The next number in that pattern, 5, 4, 3, 2, 1, 0, is -1. 2 to the -1 is 1/2. 1/2. Okay? And that goes for anything to the -1, right? If I say anything to the -1 power, that is 1 over that anything. So for example, if I say 5 to the -1, that's 1/5. If I say 8 to the -1, that's 1/8. And it's good. It makes sense a little bit. If raising to a power means multiplying by the base, then raising to a negative power means dividing by that base, right? It means dividing by that base. And that's exactly what's going on. Anything to the power of -1 is 1 over that anything. Now let's continue it on a little bit more. So we want to take 1/2 and divide by 2 again. 1/2 and divide by 2. Let me make a little room here. I'm going to take 1/2 and divide by 2. 1/2 and divide by 2. You got to remember your fraction division a little bit. 1/2 divide 2. To divide means to turn it into a fraction and take the reciprocal and multiply. This is 1/2 times 1/2, or 1 times 1 over 2 times 2. And I'm going to write that as an exponent, 2 squared. So here we have, look at this. Here we have 2 to the power of -2, 2 to the power of -2, 2 to the power of negative 2 is 1 over 2 squared. Okay? And that brings up this rule. Okay? To change the signs on an exponent, move the base across the fraction bar. Move the base across the fraction bar. Let me show you what I'm talking about. 2 to the negative second can be written over 1. And we've just determined that it's equal to 1 over 2 to the second. So you see how what has happened is the 2 to the negative second has moved across the bar to the bottom, and the negative 2 has become positive. Okay? The negative 2 has become positive. So essentially what we're doing is we're starting with 1 and we're dividing by 2 twice. Right? And just to continue the pattern one more time, and then we'll do some problems here. To continue the pattern one more time, I'm going to divide by 2 again. And 1 over 2 squared divided by 2, just continuing the pattern, is 2 to the negative third equals 1 over 2 to the third. 1 over 2 to the third. Okay? And it makes sense. If raising to a power means multiplying the base, raising to a negative power means dividing the base, and we're going to write the base in the denominator. Okay, now let's do some problems here, and I want to show you practically what that means. Okay, and I know I'm going a little long, so I'm going to try and be quick here. Okay, so let's say we've got x to the third, y to the negative fourth, over x let's say z to the negative second. Okay, we have some negative exponents. We're going to use this rule. Remember, the rule says to change a negative exponent into a positive, move the base across the fraction bar. Y to the negative fourth is going to move across the fraction bar from the top to the bottom. When it does, it's going to become y to the fourth. Y to the fourth. X to the third is positive, so it's going to stay. Z to the negative second, I put that on the bottom. Let's obey that rule, though, that says if I want that negative 2 to become a positive 2, move the base z across the fraction bar from the bottom to the top, and the negative 2 will become positive, z to the second. And so that's kind of how we apply it. To change a negative exponent into a positive, move the base across the fraction bar, whether that be from the bottom to the top or the top to the bottom. And then the other rule we learned is anything to the 0 power is 1. All right, that's it.